Hello everyone and welcome to part 3 of our Introduction to TSAssist. This is the third and final video in our Introduction to TSAssist video series. For those of you following along in the PowerPoint, you're going to want to skip to slide 34 at this point, as there's a few slides in there that are going to be just getting us set up and caught up to where we are in TSAssist. And for those of you that didn't know, we do have a PowerPoint available to follow along with these videos. You can send an email to info@tmrobotics.com to request your copy of the PowerPoint. Alright, in the third video here, what we're going to do is we're going to go through and we're going to explore some of the 3D functionality that has been added to TSAssist. For those of you familiar with the old programming software TSPC, this is a huge advance in the functionality and really opens up some very neat functionality and features that really make it easy to optimize cells and do system layouts without ever having to build a single piece. We're going to continue with our solution line 1, with our project robot 1 and file 1, the files that we created in the previous video series. To get going with this, we're going to start the simulator. Once the simulator opens up, we'll see our familiar THE400 SCARA robot. Now, in this particular layout, we do not have the 3D tree available. We closed that in a previous video. We're going to open that back up now. So we're going to go to 3D view and we're going to show the tree. That brings that back on screen for us here. We're also going to bring our file back up, our line 1 file. So we're going to go to, file 1, select file, file 1. We'll open that up as well. At this point, there's a few things that we can turn on and off depending on what robot you've selected and what features might be out there. For example, if you order the THE400 in the United States, North America, or Europe, the tool flange is a standard option. So we can turn that on in our simulator here. So we're over here. Tool flange attaches to joint 3 and 4. Right here is our tool flange. If we right click, we can display that, and the tool flange is added to the 3D drawing. Other options that might be out there, for example, is some of the camera brackets. The THE400 does have a number of camera brackets that have been pre-designed for it. We can turn those on as well. So if you specify the front bracket camera K, for example, you could display that and the camera bracket will be added. You could then put a camera on here. You could put lenses on here to simulate the sizes and shapes of that so that you can do full interfere checking with this cell later on. We'll show some of those features. For now, we're going to turn this back off. With that, we've got the tool flange activated. The next thing we can do is we can actually put a tool on that tool flange. In this case, we're going to keep things real simple. I just want to show some proof of concept here. So let's add a very basic cube or a box to the end of our tool flange. So we're going to go to joint 4. We're going to right click. And what we're going to do is we're going to add a shape and we're going to add a box. So in order to add this box to our tool flange, what we're going to need to do is we're going to need to go back to our file editor. The 3D changes are saved in the project folder, so they'll be active for all of the files in that project folder. However, we do need to have a file open in order for the robot for the software to have something to associate with. So we're going to go to our file edit. We're going to open our existing file, file 1. Now from here you see a slightly different layout. Our control panel is gone, but our tree is still going to be here. From here we can add our cube or our box. So we're going to go to joint 4 and we're going to add a shape and we're going to add a box. Now let's do a real simple box. Let's do a 50 millimeter cube. So 50 millimeters by 50 millimeters by 50 millimeters. Now if I just apply this and add this, you'll see the box actually centers itself over the tool center point. The origin of a shape when you insert it is by default the middle of that shape. So in order for this to be at the end of our tool flange, we need to actually offset the base coordinate for that cube. So what we're going to do is we're going to drop this down half of our height, which in this case is -25. But we also have the tool flange on this particular robot. So you'll see it's not quite all the way down. So I'm going to drop it another 5 millimeters, and we're going to make this -30. That will then put the cube at the end of our tool flange. We can apply that, and that cube is now added to the end of arm tooling. That will now be synchronized to the end of arm tooling, so if the arm swings around, the box will follow it. Another thing we can do to make the view a little easier to see is we can turn off the grid lines. So we can go to ground, we can right click on that, and we can turn off the wire grid to make things a little bit easier to see. The next thing we're going to add while we're up there is let's put the robot on a base. Let's put the robot on a cone, if you will. So we're going to go to World, we're going to right click on that, and we're going to add a shape to the world, which is the workspace around the robot. And let's add a cylinder. For this cylinder, let's make it a bit more cone shaped. We'll make the bottom 400 millimeters in diameter. Let's make the top 300 millimeters in diameter, and let's make it 500 millimeters tall. Now, if we apply this as is, same as before, the center of that shape is going to be centered on the center of the world universe, which is the base of the robot. So as you see, if I apply this, it kind of hides our robot. It's not going to do us a lot of good. So we need to drop the Z down half of the height. That will bring the robot so it's now sitting on top of the base. Now what I'm going to do as well is I'm going to drop that down an extra millimeter, so it's going to be 251. The reason I do that is in a few minutes we're going to go through the interfere check functionality, and what that's going to look for is any two shapes that are touching. If the robot's actually touching the base, it's going to throw off some false positives. So we're going to give ourselves an extra millimeter to be safe. So we'll apply those changes. The other thing we can do as well to make things a little bit easier to see is we can change the color. So let's change the color of our base. We'll right click on the cylinder. We'll right click. We'll set color. Uncheck the default and go ahead and select a color. Toshiba blue is good. Hit OK, and you'll see the cone is now turned a nice shade of blue. So here you can see, if we zoom out a little bit, you can see the robot. We've got it sitting on a cone. We've got our workpiece here. And we would kind of build up a very basic cell, what might be a demonstration cell in the back of the warehouse, for example. Now what we can do is we can turn our interference on. So we're going to go check interference, and we're going to turn that on. What that's going to allow us to do is find out if any objects are indeed colliding. Let's go ahead and save our changes. We're going to exit the file editor. We're now in our simulation program. We're going to select our file, go back to that file 1 that we wrote before. That'll bring up our program here. So with the simulation open, we've selected our file. I'm going to slow things down a little bit so we can see what's going on with this. We'll set it to 20%. So now as I run my file with the interfere check on, we'll actually see when the objects touch, they're going to turn red. So we can see in this particular case, no interference, and then we have some interference. This obviously could be compounded to a very complex cell. If you were to build a large cell, you could be importing all of your safety, your guarding, your tooling, your camera, your fixturing, and you could be using this to monitor and make sure that as you run your program, you're not taking out any expensive equipment. That's the conclusion of part 3 of our introduction to TSAssist. If at any time you've got any questions or you would like more information on this, please feel free to reach out. info@tmrobotics.com is our email address. Be happy to answer any questions that you might have and get you any other assisting documentation. Thank you again for checking out our presentation, and stay tuned for more videos in our TSAssist series.